All right, so then in the previous segment, we talked about the first law of thermodynamics, which says that you cannot create or destroy energy, which is to say, whatever energy you start with, that has to be the same amount of energy that you end with. So in this picture here, you can see that you start with energy that's coming from the sun, and eventually it ends up as energy that's being used to pedal the bicycle. However, that never really happens, because then you also have the second law of thermodynamics. So in the second law, it's going to say in any process, some of the energy that you put into a system must be wasted in the form of heat. So that in the picture that was above, that energy that came from the sun, a lot of that energy is wasted and doesn't go into the making of the corn. So some of it is released as heat into the atmosphere. Okay, then when you eat the corn, some of the energy that you get out of the corn is not going to be used to make up your muscles. So some of it is going to be converted into heat, and you know that your body has a certain temperature. So that heat in your body is coming from that wasted energy. And then when you go to bicycle, only part of the energy that comes out of your muscles is going into pedaling. And so some of that energy must also be turned into heat. And remember, you're sweating. And so that's where some of that heat is escaping from your body. So when you have to do a problem like this, so if we go back to this one, we're assuming that no energy is wasted. So in this problem, all of the energy you started with was equal to the energy that you ended with. So this one here is not a very realistic problem. So if we wanted to make it realistic, we would need to add an additional term to the right-hand side that would say heat. So how much heat is given off in the system. And we're not going to do that. So if I give you a problem like this on the exam, you can assume that all of the energy you start with is equal to the energy that you end with. But I just want you to notice that according to the second law of thermodynamics, in any energy conversion, some of that energy must be released in the form of heat. Okay, then we also talked about what power was. So P for power, and I like to make it a cursive P because a regular P is going to stand for pressure, at least according to me. So I like to use the cursive P for it. And it's going to be equal to the amount of energy that is going to be generated by a system, or it could be the amount of energy that is used by the system in a certain amount of time t. So this is energy in joules, this is time in seconds, and then a joule divided by a second is a watt. So the units for power is going to be watts. So it's going to be the rate at which energy is either being generated or is being used up. And when I say the word used up, I do not mean that the energy is just disappearing into thin air. It's being converted into some other kind of energy. Okay, and then sometimes that energy might be in the form of heat, and then the heat escapes so that you can't grab it and use it for anything. So here's a worked out example of how you might use that formula. Okay, let's take a break, and when we come back, we will talk about simple machines.